Good afternoon, everybody. We're back. I'm Sunil. We're here to talk more machine learning. I've got Slava here with me from the MXNet team. Um, we're going to talk about, so we're launching model server for MXNet, Apache MXNet. So we're adding the container support for scalable model inference. Yeah, maybe we can just talk about like, why is MXNet cool?
Oh, okay. So if we're going to speak about MXNet, I actually have to say two things. First, MXNet is scalable, which means speed. And this is one among the other reasons why the AWS actually make it our deep learning framework of choice. And the second one is simplicity. It's really simple to use it. So basically, first, the speed usually attracts you and makes it you want to use it. And the second one keeps you in.
Right.
So it's really cool. Just give it a try.
And may I add, like, we also have Gluon support, so which is on top of MXNet. So the imperative interface makes it really easy and intuitive for developers to pick up on deep learning.
Yeah, and we kind of even have a book, straight up, that basically teach you how to use it based on Gluon. Yep.
Right. Maybe you want to talk a little bit about what's the MXNet model server first?
Sure, yes. So basically, let's say you have a model, right? You have a model that is ready for the production deployment. So how and where are you going to deploy it?
Right.
You actually have several options. You can build from ground up the software for precisely your model, support it and deploy it somewhere. Or you can go to the services like SageMaker, deploy it completely in the cloud. There are a lot of customers who want to be in between. They want to deploy to their own instances, but they're not ready to deploy from ground up the system for production deployment.
Yeah.
And the model server for Apache MXNet sits exactly in that spot. So you can think about it as a Tomcat in Java world. So Tomcat that you're using to deploy applications, but this is Tomcat for deep learning, where you can just deploy a model. And by the way, even though MXNet in the name of the product itself, model servers for Apache MXNet, it's not only tied for MXNet, it's actually capable of serving any model that is using Onyx
that's
for
wonderful.
representation.
Yeah. Maybe you want to talk to our developers here. What's Onyx? What's the story there?
Sure. So there are a lot of cases when you're designing the model, let's say in the PyTorch, right? And then you want to deploy it to somewhere. But this deployment environment not necessarily capable to work with the PyTorch model format. So the Onyx is basically a format of representing your model that can be shared between many deep learning frameworks. So essentially, by supporting Onyx, MXNet model server is capable to serving any model. You can even use a TensorFlow, because TensorFlow already have a converter to Onyx. So yes, this is what Onyx is.
That's really cool. Can you talk a little bit about how you work with containers in the model server?
Okay, so basically with current deployment, we're introducing containers that inside already have MXNet model server. This basically means that now you can deploy your model to anything that supports containers, like ECS, Kubernetes, EKS, or Fargate, right? So basically, we introducing the last step that is needed for easy deploy of your production model to the production system.
So I'd love to see if, demo, but maybe if people are just joining in, you can summarize what are we launching today?
Okay, so we're launching support of the containers for model server for Apache MXNet. So now you can actually use our containers to deploy your model to any environment that supports containers.
Yeah.
And I have a demo for this.
I'm excited, yeah.
So let's actually switch to my screen. Let me start with the picture of the kitten, because everyone loves kitten, right? So, yes.
We all do.
Let's say you have a model that knows how to identify type of the kitten in the picture. So this is a picture that you're going to use for testing. If you want to deploy this model to the production, you need to do 3 simple steps. Step number 1, you need to see that MMS is actually correctly working with your model. This is a very simple step. You need to install via the pip MMS on your machine. This is actually deep learning AMI on EC2 instance.
And for people who don't know, this is the best way to get your environment set up on AWS. So use the deep learning AMI. We have an Ubuntu and Linux version, Amazon Linux version, all the drivers for CUDA, all the deep learning frameworks that are popular and the data science libraries all packaged. So it couldn't be easier to get your deep learning set up.
It just worked.
Yes.
Right. So this is basically the package, and the only thing that I need to provide is URL for my model. As you can see, URL can be any public URL, nothing else. So this is basically one liner. I have started the process, and now my model already running. Let's just double check by requesting a ping, just to verify that my server is running.
Good.
And let's actually run the inference. I have a predefined model for the inference that I'm going to copy paste. This is a request, post request that I'm going to execute, and here is the result. So according to our model, this is Egyptian cat. I have no idea what it is Egyptian cat, but let's just run the model.
It's sometimes you've your training data doesn't have kittens, so yeah,
Right.
put more kittens into your model, like training data. That's the key learning.
Yes. So okay, now you see that MMS is capable to work with your model. The second step would be to create a container. The only thing that you need to provide a config. This is example of the config that basically container will be using underneath. And
Right.
to get started, you just need to change one line. This line is the line that sets the model. Again, you're
Yes.
providing this one-liner and you start your container. Container is essentially just a one-liner to start the container. Let me quickly find, this is a one line. So
Sure.
as simple as this. I'm starting the container with my config, and let me double check that it's actually running the inference. Let me copy paste my command again. The same command basically. I'm going to execute inference for the same model, so I'm going to send the same signal. I'm just changing the port to 80 because this time I have the port mapping. And we have the same, Egyptian cat. Okay,
Nice.
so now we have a container, right? Now we're absolutely ready to deploy container to the production system. As of now, we actually have released the article how to deploy MMS on the Fargate to actually do absolutely serverless inference in the production
This
scale.
is amazing. Like, we should take a moment. Like, the entire ML pipeline on the inference side has been simplified. Because I don't know if people realize this, but we often give emphasis on the training aspect of model, and that's where we spend a lot of time thinking. But if you think about production cost, a disproportionate amount of cost is actually spent on the hosting and inference side. So it's really important that you think through that piece of things. And with these new releases, we are simplifying. You have the option, like Lambda inference. You've got SageMaker inference now with the MXNet model hosting server. We are simplifying this hosting piece.
Right. In this particular article, you will create the absolutely serverless cluster based on ECS. This is like a high-level overview of the cluster. We will have a load balancer on front that actually serving the traffic and sends the traffic to the Fargate task underneath. And we're collecting all the logs, metrics, and CloudWatch, so we can use these logs metric to decide when you want to scale up your cluster or scale down. And I'm not going to actually walk you through to the actual cluster creation right now, but let's say you already finished the article, and then you will have load balancer. So if you just copy paste the DNS name of the load balancer at the end of the article, you can basically run this same inference. So first let me ping to verify that, our load balancer actually healthy. And now again, let me go and copy paste inference of the same kitten that I'm going to send live to my ECS Fargate serverless cluster with 3 tasks, and I will have the same result, Egyptian cat. Right. So this is fully serverless inference on ECS with MMS and Fargate.
Oh, this is great. I don't know if you can go back to the config file. So having worked with web servers a long time back, I've built a lot of web servers in my life. What I love is the options, right? Like log rotation. I mean, some of the things that people sort of forget, at scale, what can happen. So it's great to see me, when I see that, it tells me you've thought through all that you need to operate at scale, which is really important for us at AWS because we're not only thinking about we want to make sure the products actually scale, and glad to see that are being incorporated into a product like this.
Yes, and basically they said the only thing that you need to change is one line with the model, but as you go, you can actually tune whatever you want, like port that actually is a server been listening on proxy or anything you want, right? And if for some reason you do want to run it in your premises, you can set up EKS or ECS just with the EC2 instances, and you've done. Yes, do we have any questions from the internet?
I think people have been happy I don't see any questions here, but just to, maybe we can just start summarizing, right? Like, how, how can customers start? Like, let's go there. Like, how can somebody get started?
Yes, so with this said, you just need to do a 3 simple step. You're basically spinning up a deep learning AMI or any environment when you do want to test your inference. You're installing simple PyPy package that already have model server in it, and then you're just testing your model with this MMS server. And basically, the only thing you need to do to start it is the link for the model. We do have a model that has a tons of already pre-configured, predefined models on Onyx that you can play with. Then you can actually, the second step, you do need to prepare a container. Actually, MMS capable of running more than one model at the same time on the same server. Yes?
So yeah, I mean, just to sort of summarize through, I think here you have a model, right? Like now you want to build an endpoint. So what you can do is with the model server, where we basically have a config file that's shown here, you can just plug in your config file and the model in the config file, and then start a scalable server. Like that's the first version, the simplest version that the model server brings you. But the additional capability we add today is you can bring in a container, because you can have dependency in terms of your libraries, or you're doing something more sophisticated. You can bring in your container and run it in the model server with a similar config file. So that's the key here. But moreover, you can get all of this on Fargate and have a completely, hands-off approach to getting it hosted and having a scalable endpoint. I mean, that's the key here. Like, that's the end-to-end story.
And I just wanted to mention for our power users, if you're planning to use MMS for on your particular instances, CPU container is optimized for Skylake CPU, which is essentially our C5 instances, and of course GPU1 optimized for our P3 instances with using NVIDIA Volta underneath. Just a piece of information to keep in mind when you're actually planning to bootstrap a cluster on your own instances.
And what's the link that people should go to check this out?
Everything is available in our article that basically I'm showing right now. So go to an official GitHub AWS Lab MXNet model server and check out the latest article, MMS on the Fargate.
Yeah, so the code's available, guys. Go check it out. AWS Lab /MXNet model server. Learn how to build a scalable endpoint end-to-end. Bring in your container and use the MXNet model server along with Fargate to build a scalable endpoint. All right, thank you guys.
Thank you.